Hey everyone, welcome to the channel and also this new mini-series I'm starting on Kaggle and beyond just Kaggle, how to start a machine learning project and carry on and improve as you go. Kaggle is, I think, a really great platform, especially if you're doing machine learning, because it really helps you hone your skills. Back when I was in academia, doing research and studying, it was a great way to sort of learn these things because people have so much interesting information and skills they share. And then even to the time I was working at companies like Google and Amazon doing software and machine learning engineering, I still kept up within it and it still helped me improve my skills because there are so many things to master and there are so many resources to learn on Kaggle. So if you're interested in that and you want to start a project along with me or see how I start a machine learning project, this is going to be the series for you. And if you like that type of content, I do a lot of it here on this channel. So if you are interested in that, I would appreciate if you consider subscribing. But without further ado, let's jump onto my computer so I can get us started with Kaggle and show you what we're going to be doing. So here we are on the Kaggle website. In case this is your first time here, kaggle.com is the website link. I'll link it in the description. But if this is your first time here, I recommend checking out the competitions tab first after you've created your account. Here you'll see all the ongoing competitions. There's usually a lot of interesting ones. Now, if you do want to follow along with this tutorial, we will be doing this Common Lit Readability Prize. And what this is we are given a number of different essentially excerpts or passages, and we have to rate them. You can actually come down here. This says a little bit about the competition. Where is it? It's under evaluation. That's not quite it. Where is, one second. Here we go. So if you go to the data tab over here, you can see it tells us about the data. So we get in all this data. The excerpt is the primary thing here, some passage, and we have to predict the target, which is the reading ease. And this is on some scale, some numbers, I guess, of how difficult this passage is to read. And yeah, that's essentially what we're doing. So you can see the data is down here. We have test data, training data. And I really just want to jump right into this. So to get started, we're going to click on code over here and go to a new notebook. And this will allow us to start, as it says, a new notebook. So this is like a Jupyter notebook you would find. I'm just going to go ahead and delete this. The first thing I will actually do is just do some imports. These are my standard imports: NumPy, Pandas, Matplotlib, and Seaborn. You use these for pretty much everything I start out with. And what we are going to start off doing in this notebook, and even before we try and solve this problem, is we're going to do an exploratory data analysis, or EDA for short. You'll see all sorts of these kernels if you're looking through Kaggle, and that is because it's incredibly important to do them, where we essentially take a look at our data, see what we have, see if there's any interesting patterns maybe we can exploit, because if we don't understand exactly what is in our data, well, we're not going to be able to use it to its fullest. So that is why we're starting with an EDA and why you always should too when you're working on Kaggle. So I will name this YouTube, or let's do Common Lit EDA. Nice and simple. So what we're going to want to do is import the data. What's really nice is you can do this on your desktop. Oh, is already used. I probably have a V2, we'll say. What's really nice, or YouTube maybe. What's really nice is if you're doing this on your desktop, you can just download the data from the site. But if you're doing this on Kaggle, you can click on the Add Data button on the top right here, and we should be able to find competition data, Common Lit Readability Prize. And just like that, we've loaded up the data. On the right, you can see the file system. Let me zoom in a little bit just in case. This should be big enough, hopefully. So we already have the data. We have our imports done, and I'll start up, I guess. You can see we're using Python. You can also opt to use R. But yeah, let's start looking into the data. Let's really dig into it. I did copy this over, so I will put this here. This is, oh my gosh. There we go. This is the data. So there's these 3 files: train, test, and sample submission. We'll start out by looking at the training file. So the first thing, did not mean to do that. The first thing we are going to want to do is load the data. Pretty simple, right? So this is fairly simple. We just specify the directory, which is the Kaggle input directory. And then under there, we have another file for this specific data set. And then we can use OS, the OS thing, to join these paths. So the data directory with the train CSV. So these are the paths for the train data and the testing data. And let's go ahead and load these up in Pandas now. To do that, we just do a read CSV with Pandas. So pd.read CSV, given the path. If we do this, Now we should be able to do two things. Let's print the lengths of these data frames to make sure we're getting the right amount of data. I believe, if I remember correctly, the train data set should have around 2,800 something samples, and the test one should be 7. Yep, so that looks good. Let's go ahead and print out the head. So if we do train.df.head, this will give us sort of an overview of the first few, or the heading of, not the heading, but the first few samples from this data frame. So you can see we have the ID, the URL, legal stuff, license, probably don't need to look at that, but then the excerpt. Now we can't see the full excerpt here, so maybe we'll print those out in a second. We can see the target. Now the targets here do look a little bit weird. If this is your first time looking at this, didn't mean to do that. Let's reload this real quick. I didn't, so the targets there did look a little bit weird though, right? It's like a negative 0.3 and I think we had like a 0.5. So it's negative, positive. We can't really tell what the range is. So that's going to be one thing that's important in this data analysis, figuring out what that range is and what we can expect. We can also view the tail just to see if there's anything different. Here you can see they do have some URL legal stuff and some licenses. So maybe we want to keep in mind that lots of those, or some of them, seem to be null. We can look at the test DF, and it looks mostly the same, except for you might notice we don't have the target or the standard error. Now, if you read the data or the descriptions they give you, it will say that the standard error is just they have multiple human raters give target numbers, and the standard error is the standard error of those targets. So looking at the standard errors, it looks like most of them we see right now are around 0.4, 0.6, but we'll take a deeper look at that. So the next thing we want to do is look at some examples. So to look at those examples, we'll just go ahead and print one out. So let's print the last one out. No reason in particular to do the last one, but why not? We can see we have the whole excerpt right here. So it's fairly long. Animals are made of many cells. Oh, lovely. So just want to see if we catch anything weird, you know. Nothing, everything seems as we would expect, just some random excerpts. So let's print 5 more and see what we get. So we're just enumerating through the first 5 dataset entries and printing out the excerpt. And yeah, I mean, these all look pretty standard, all in English. But it's very important you do this, because what if one of these was in Spanish and you weren't expecting that? Well, suddenly that would be something you would want to account for, right? So that's why we're going through this step by step. We don't want to skip any of these steps. We want to make sure we understand the data fully. So now that we've sort of seen what the data looks like, let's look at, or at least some examples, let's look at it graphically, because we can only see so many examples by printing things out like this. But by using graphs and analytic data, we can start really getting a better picture. So one thing we can also do to start looking at this analytically is do a train df.describe, and this will tell us a little bit about the distributions of these. So we can see the percentile ranges, the minimums, the standard deviations. So specifically for the target and the standard error, because these are the only 2 numeric categories. So it looks like the target's a mean of about -1 with a standard error of about 0.5. Interesting. Yeah. So you can feel free to look over these. These look to be roughly, so I guess the max and min are kind of important here. It looks like we have a minimum of -3.67 and a max of 1.7. So roughly -4 to 2. That'll be good to know when we're scaling our data. Other than that, it looks like the standard error doesn't get too large, which is probably for the better. This could also tell us something about the number of reviewers on some of these, but we can't get to, maybe not really. Maybe I take that back a bit. Let's start looking at graphs though. So the first thing I want to look at are the lengths of these excerpts. That's something we are not seeing here. So let's do this. Oh, that's here we go. Let me make some cells below this so it's easier to see this. Here we go. So we can get the length of these excerpts. I'm just going to apply a length function to this. So this will get us the amount of characters in each excerpt. Then we can use Seaborn to do a distribution plot. KDE false will just mean we're not going to fit a line to this. No reason to do that. Just in case you're curious of what that does, it just has this line. I don't know why. We don't need that. But looking at this, it looks like we get a fairly Gaussian distribution, around 1,000 characters on average, spanning anywhere from the a little less than 700 to a bit over 1,300. Okay, this will be important to know for when we are making our model. We want to know how many tokens we can have, right? This is not how many tokens we have, but how many characters we have is a good analog for that. The next thing I want to look at, before we were looking at some examples, that just to check, if it was English, seeing if there were any weird characters. We don't see any from the examples, but let's go ahead and check that programmatically. So for checking unique characters, I went ahead and wrote this little script. It's nothing too complicated. So we create a set of all the characters, or just an empty set. Then we go through and we essentially add every single character in each excerpt to this characters list. And then we just print them out. So here we can see, okay, so this is interesting. We have and it's sorted. So in terms of character numbers. So let's see, we have some special characters. We have some numbers, uppercase letters, lowercase letters. That's all expected. Here though, I will say is a little bit weird. You were saying probably not too weird, but we have like a degree sign, a plus minus, a nano, a weird thing for a fourth and a fifth, this AE. So, and then some accents. So why might this be important? Well, for one, maybe these characters, I can imagine having a nano symbol would probably be on some of the more complex readings. You're probably not going to have a third grader level reading with one of these symbols. So it's probably good we checked this. And I guess maybe it's good to know there are going to be accents and stuff, because essentially what we want to make sure is that our model accounts for this. So if our model doesn't account for these characters, we might want to change it so that it does. So it's good to know that all of these exist. We can go ahead and add on one more minor thing to this, and that is just going to be writing out the characters right here. The associated character numbers, I'm not sure how to say it, but the integer values associated with these characters. And the reason I'm doing this is because I want to make a new feature for the excerpts that have some of these weird characters over here, or some of the characters with accents. And the reason for that is maybe we can check if there's any correlation between these characters and, a harder passage. So let's go ahead and make that feature. Here's a small script to do it. We are just looping through all the characters in the set and adding all the quote unquote hard characters to this set that we made. Now, ORed, this function, will essentially take a character and give you the numeric value. So based on this, we can see if we go to 176, 176 is one of the first harder characters, and that ends at 339. Everything after this is pretty standard. So any character in between those ranges is going to be considered a hard character. Then we can go through our data and apply a function to each excerpt to check if there's a hard character in the excerpt. And if there is, we will set the column to true. So we can sum this and see how many different instances of hard characters or excerpts with hard characters there are. And it looks like there's 128 out of 2,800. So not that many, but not negligible. We can actually go ahead and just to show you what this looks like, if I copy this over this column, you can see most of these are false, but this would be true if there was a hard character in one of these, or in any of the excerpts shown here. The next thing I want to do is, up here we took a look at the amount of characters. Let's take a look at the number of words. We'll probably get something pretty similar, I would guess, but just to be sure, words are probably a better approximation of how many tokens we can expect. Here we go. This one actually is not Gaussian. Looks like it ranges from around 140 to 200. So because of that, I think on average, it depends on the tokenizer you're using for NLP, but if we're feeding stuff to a deep model, right, and we need a tokenizer, even if we're using something like BERT that uses, I think, sentence piece or word piece, I think most words tend to on average be anywhere from 1 to 3 tokens. So we're probably going to want to easily support up to 500 tokens, would seem like maybe a good range. And that's something we can maybe look more into later. The next thing I want to do is, we know what the excerpts sort of look like now. We've got a good bit of data on them. Let's start looking at some of the other variables. The other most important one, I'd say, is the target, because it's what we're trying to predict. So let's graph another distribution of this target. So this one looks fairly Gaussian too, which is cool. So it's centered at roughly -1, which we saw in the analytical view. And here we can again see that it's from around -4 to +2. The big amount of data we're getting here is that this is roughly normally distributed. One reason it's important to know this is, we're not going to have as many samples at the extreme ends here, which might make training hard, or we might want to come up with a strategy to help fix that. Something to keep in mind, and again, that's why we have to look at all these things. We're finding out data. This data is all stuff that can help us later on in the process. Next, I want to jump back to where we are before. Sorry if I'm jumping around a bit. I could have organized this a bit better, but we got these hard characters, right? So let's now see if, because now we're working on the target, if the target does correspond with, or if there's any difference with these hard characters, or sorry, if when there is a hard character, if we can expect harder passages. Now I'm going to use a violin plot for this because this hard character is a true or false value which means there's only going to be 2 different distributions here. So we could either like overlay these distributions or something, but violin plots are a great way to do this. So when I graph this, you can see this is what violin plots look like, and these are the distributions for when there is no hard character on the left and when there is on the right. And I haven't yet tested if this is statistically significant, maybe something we could do later, but just looking at it, these results look like there is indeed a correlation. You can see that when there is a hard character, it looks like on average, we're getting roughly, almost an entire point or an entire one, I guess there's no unit here, but we're getting an entire one more difficult. I believe -4 is the most difficult, but I could be wrong there. We'd have to go back and read the data set. Or does it say here? Let's see. It does not, but we can go back and look at that later. But there is a difference, which is interesting. So we'll want to make sure our model accounts for this. If we run our model over both of these different subsets and we see that there is no difference, well, clearly our model will not be accounting for this, and we'll want to make changes based on that. That's where this could come in handy. The next thing I want to look at is whether or not there's a correlation between the excerpt length and the difficulty or the target. So let's do a scatter plot for that. In this scatter plot, we will essentially just, I hope you know what a scatter plot is. We're just graphing a bunch of points. So each point on the x-axis, we will have the excerpt length, and on the y-axis, we'll have the target. And here, this does not look super convincing, but we can tell there might be a small negative correlation here where the excerpt length means a lesser target or a more negative target. It's hard to tell, and in cases like this, what we can do is we can actually do a linear regression and see if we get anything statistically significant, or even not statistically significant, but just see if there's an interesting R-squared value. So this is an easy way to do that in NumPy. We can do this core-coef function will essentially fit these, or give us a correlation matrix at least, and then we can calculate the R-squared from that correlation matrix. If you've never worked with this before, what an R-squared value is it's the goodness of fit, you could say. By rule of thumb, an R-squared 75 or 0.75 and higher is considered very good. 0.5 and higher is considered okay, and then around 0.25 is considered not so good. So 0.13, not so good here. That being said, there still does seem to be a rough correlation. There's just a lot of variance. So this could maybe be a factor in predicting, but it's not a super strong factor. It's not very predictive, maybe slightly though. Next thing I want to look at is the standard error distribution. So we can go ahead and just do another, a distribution plot. And you've probably noticed by now, whenever I want to look at a variable that's a continuous variable, I usually start with a distribution plot to see what the distribution looks like. So let's go ahead and look, and it looks like it's centered around 0.45, a little, definitely more than 0.4, but a little bit less than 0.5, and it is left skewed, which is interesting. That's probably for the better, but it is interesting that we have a few cases out here where there's a high standard error. So maybe these could be counted as outliers when we do our modeling. Maybe, I don't know, we'll have to look into it more. Next thing we want to look at is a correlation between the target and the standard error. I don't know what would come up here, but we can check. So just another scatter plot. On the x-axis, we'll have the target value, On the y-axis, the standard error, and let's see what comes up. Okay, this is very interesting, right? We don't have to do any sort of fitting here to see there is a very clear correlation. Now, there is a little bit of variance here, but nevertheless, something's happening. So what is happening? Well, for one, I see an outlier all the way here, down here at 0, 0. So we're probably going to want to figure out what that is and probably take it out of the data set so it doesn't hurt our training. It's just one sample, but to be safe, you know? The next thing is it looks like towards the extremes of the targets, so around -4 and around 2, we start to see much higher standard errors. So the more extreme the target is, or the higher, or the further away it is from the mean, the higher the standard error tends to be. And that makes a little bit of sense, I would say, right? When people are rating these passages super hard or super easy, more people are likely to disagree because people do tend to usually bias their estimates toward the mean, I'd say. Maybe I'm making that up off the top of my head, but this is really good data. We could use this to do a number of things. One, we could count maybe some of these up here as outliers because they're sort of off on their own. Maybe that would be a bad idea though. Maybe we actually need more of this data and we could find more that fell into these categories. Or maybe we could weight our training based off the standard error, or there's a number of things we could do, but this is a really good finding. And again, this is why you can never skip your EDAs. You find interesting stuff like this all the time. So I'd say that's the most interesting finding so far, really. The next thing I want to do is, where is it? Let's look at this outlier real quick. I'm very curious. So we have this ID and an. The sun was shining in a cloudless sky. Let's look at the excerpt in more detail. Oh, print. Hopefully this works. No, I think if this doesn't work, I'll give up. But oh well, it's fine. It's fine. It's not a big deal. But the excerpt from just this does look pretty normal, but the target and standard error are, yeah, they're 0. So this maybe is an issue with the data set. Can't really say for certain, but we will probably want to get rid of this when we do our training. Anyway, I'd call this a fairly thorough EDA. There definitely are more things we can look at. We can look at word clouds, see what kind of words pop up, and other graphical things. We can look up other combinations of these, but there isn't too much data here, to be honest. So I think this is definitely a good start at the very least. I would be comfortable looking at this and saying, okay, let's start building a model with what I know about this data. So let's go through again and wrap up our key findings. The first thing was, and I actually have written them down already, so I'll go ahead and paste them here so we can all see. The key findings are essentially first just the distributions of the length of excerpts, the fact that they're mostly written in English with some special characters on occasion. The difficulty, or the targets, tend to range from -4 to roughly 2. Most of the targets are follow a roughly Gaussian distribution, which means around the edges we have less training samples. The standard errors are all within the range of 0.4 to 0.7. That's probably for the better. None of them are way too out there. The distribution of standard errors is left skewed, in case we can abuse that. Then targets near the extremes, probably the most interesting finding, have higher standard errors in a very predictable pattern. And the last finding is there is a single definite outlier, and some of these other high standard error data points could potentially also be used as outliers. So these are the findings we found from this, and I hope this was something you found interesting. I do a lot of content like this and I plan to do more. So if you're interested in these types of machine learning videos, please do consider subscribing to the channel. It really does mean a lot. I do plan on releasing a few more Kaggle videos, by the way, so keep an eye out for those. But that is it for now. So thank you so much for watching, and I hope to catch you next time.